Hello, dear student. How are you? I hope you are will be fine. So let's start today lecture. Today is the lecture number 16th of crystal field theory. And today lecture we will be discuss about crystal field theory. The topic name is limitation of crystal field theory. There is some limitation of crystal field theory. There are many advantages, many application of crystal field theory, but somewhere that have little bit explanation, a little bit limitation. What is the limitation? So let's start today topic. Today topic was very short, very easy topic, too much easy. So let's start the topic. The first limitation of crystal field theory, as the crystal field theory tell us about d orbital, tell us about information, tell us information about d orbitals, while cannot explain the bonding in which s and p orbital involve. It is the first limitation. um, Crystal field theory tell us about the information, tell us information about the d orbital, and that d orbital have each set t 2g sets, among them transition will occur. So it tell about different information like regarding d orbital, while it has no explanation about s orbital, p orbital, or px orbital, pyz, px, py, pz. It has no information about these orbitals. It have only information about dxy, dxz, dyz, dx square minus y square, and dz square. So this is the one big limitation of crystal field theory. The next limitation of crystal field theory is it cannot explain pi ligand orbital. It cannot explain pi ligand orbital. There is some ligands that can form pi orbital. I already told you in previous in few lectures ago. I already explained you that there is some that pi ligand acid pi acid ligand are the strongest ligand. Pi acid ligand is one of the strongest ligand, one of a strong ligand. It is very strong ligand. So it has no, it is very strong ligand because ligand also share electron pair to the central metal atom, while central metal atom also share to the vacant orbital of ligands like CO, carbonyl carbon, or carbon monoxide. In case of carbon monoxide, it have one lone pair, the carbon, and one empty orbital. So this orbital can accept the lone pair, it can accept the electron from the central metal atom. That's why the bond, the interaction between the central metal atom and this ligand, pi acid ligand, will have strong ligand. But the crystal field theory has no explanation about the pi ligand orbitals like that. So this is the second limitation of crystal field theory. The third limitation, next limitation of crystal field theory is, let's take position, correct position of the camera. So the next explanation, it has no explanation about, it has no, the third limitation of crystal field theory is the no proper explanation, no satisfactory explanation about, no satisfactory explanation for the relative strength of, relative strength of ligands and the spectrochemical series, It has no explanation about spectrochemical, no proper explanation about the strength of ligands, that which one ligand is strong and which one is weaker. No have proper explanation, not have satisfactory explanation about spectrochemical series. Or spectrochemical series is a series of ligands in which we can, and which experimentally that this ligand are very strong ligand, and this is weak from this one, and this is weak from this one. So this is one strength word series. This series has no, the crystal field theory has no explanation about this series. So let I am showing just you the spectrochemical series. What is the spectrochemical series? You can take screenshot because lack of deficiency I am cleaning the board. Thank you. This is spectrochemical series. So how can you define the spectrochemical series? The common ligand can be arranged in order of their increasing splitting power to cause d orbital splitting. This series is called spectrochemical series and is given as below. For example, iodine is less than bromine, bromine is less than chlorine, chlorine is equal to is approximate congruent to SCN, which is congruent to N3, which is less than C2H5. And this is chemical synergy. The strength of the given ligand are increasing order, and hence so CO and CN is the most strongest ligand according to spectrochemical series, while iodine has the most weakest ligand according to this series. So iodine will cause very little, very small crystal field splitting, while CN or CO will cause very large crystal field splitting. This called spectrochemical series. While crystal field theory have no explanation about this spectrochemical series, has no satisfactory explanation, has no proper explanation about this spectrochemical series, that what is the reason behind this, how can you differentiate, how can you explain the strength of these ligands on any basis. So it have no proper explanation. Also, the another example is the another limitation. Limitation number 5 is, sorry, the pen is not proper working. Let me change the pen. The another limitation of crystal field theory is crystal field theory has no proper explanation. This theory consider the metal and the metal. This theory consider the metal and ligand interaction as purely ionic, but doesn't consider partially covalent. It doesn't consider the interaction partially covalent, while there is some example, the covalent in nature, while there is some example, there is some complexes which contain the covalent character, so that's why ligand field theory are failed there. For example, there is PTX4. This is one complex for square planar complex -2. This complex has experimentally some covalency character, but crystal field theory cannot explain the covalency character. At crystal field theory says that the metal and the centrometer atom as well as the ligand will consider as purely ionic. The purely electrostatic interaction will be present. But in case of this complex, crystal field theory failed. So crystal field theory has these five limitations which we are discussed. I hope you will be cleared. Thank you. This today's very short lecture. That is the last lecture of crystal field theory. Okay, thank you. Best of luck.